All right, this is the recording of the full review for exam 2. I hope that you have been using desmos.com/calculator to check your answers for the homework and the quizzes in this unit. It's very helpful, and it's also a good way to visualize each of these graphs. So here is how to find Desmos. You just go to desmos.com, and oftentimes the front page will tell you open graphing calculator. If not, go to math tools. Scientific calculator is the one that will simplify fractions for you. Here's the decimal, but if you push that button, it will give you the simplified fraction or the fraction in simplest form. So that would be desmos.com/scientific, but this unit, you're going to use graphing. All right, so back to this. It's asking us to graph the line y equals 1/4 x. So there are 3 different lines they want you to put on here. Y equals 1/4 x. There is no y-intercept, right? Because we're thinking about y equals mx plus b. And if we superimpose what we have, y equals 1/4 x, and then there's no plus b, y equals 1/4 x. There's no plus. You can also think of that as plus 0, right? And remember that b is going to tell you where it crosses the y-intercept. So it's going to cross the y-intercept at your b, which is 0, right? And then that m is your slope. Your slope is always rise over run, right? So here we're starting at our b, which was 0. We're going to go up 1, and then we're going to go to the right 4. Up 1 to the right 4. The exam will always want you to plot 2 points to finish your line. You can also, so why did we go up 1, right 4? Because up is positive on the x-axis, and then right is positive on, up is positive on the y-axis, right is positive on the x-axis. So we're going positive, positive. You can also go negative, negative, right? Because negative divided by negative is going to give us a positive number. So you can go down 1, left 4. Okay, so that will be the line. Y equals 1/4 x. Good. Y equals -4. Y equals -4 means anytime you have a y equals and there's no x value, you're just, if you were to make a table of your x, y values, right? For this one, when our x is 0, our y is 0. This one, when our x equals 4, our y equals 1. When x equals 8, sorry, that should be over here. When x equals 2, when y equals 2, x equals 8, right? Here, it's just y equals -4. If I was to make a table of y equals -4, no matter what x value I had, when x is 0, y is -4. When x is 1, y is -4. When x is -4, y is -4, right? Because there is no x for me to substitute in. It's just y is always -4. Can we find y equals -4 on the graph? Where does y equal -4? That would be the y-intercept, right? And then everywhere else, it's -4. So when x is 1, y is still -4. When x is -1, y is still -4. So there's our line for y equals -4. And then if we think about x, it is similar, right? So I have x is -2. There's not even a y. There's not even a y in the equation, right? So x is always -2, no matter what y I can think to put in because there's nowhere to even put that y in, right? So when x is -2, y could be 0, y could be 10, y could be -5, anything, right? Where is x equals -2? Right here, where you find -2 on the x-axis and you draw a vertical line. When y is 1, x will remain -2. When y is -2, x will remain -2. So that's the third line you want to graph. Let's see when we go over to Desmos what it will tell us about these three. Y equals 1/4. Make sure your x isn't down here. That's going to give you divided by x. You want it multiplied by x, so the x needs to go next to it, or the x can go up here. Okay? So y equals 1/4 x. Remember, press edit list, create table, and it will give you these values. So here's 0, 0, right there. Here's -1, -2. If you don't want decimals, you can keep going. 3, 4, 5, 6, 7, 8, until you get to whole numbers. So when x is equal to 4, y is equal to 1. You can find that right here. When x is equal to -8, y will be equal to -2. So you can find these points on the graph. All right, so that's y equals 1/4 x. I'm just going to delete the table so we have enough room. Next one was y equals -4. There's our straight line. Here you can make a table. When x is -2, y is -4. No matter what x is, y is still -4. Last one. X is 2, -2. All right, and so that should look like what we have on our paper. You cannot do the table, it won't offer a table unless you have the whole equation set equal to y. So this offers you a table because you have y equals. This offers you a table because it has y equals. Because this one has x equals, it's not going to offer you that table. But that looks like what we graphed. Question 2, use the intercepts to sketch the graph of the function y equals 2x plus 4. You know what? They're not gonna know if you use the intercepts or if you just graphed it using y equals what you know about y equals mx plus b. Y equals mx plus b, we talked about it with y equals 1/4 x. This is going to be where your graph crosses the y. Include that positive sign, right? And then this is going to be the slope when you move up and over or down and over, okay? Here we have y equals 2x plus 4. So our b is +4. Where is it going to cross the y-axis? At +4. So let's start right there. Good? All right, our slope is now 2. Remember, our slope is always rise over run. M is change in the y-axis over change in the x-axis. Okay, and for this one, we have 2. 2 is also the fraction 2 over 1. So we're going to start at 4. We've started at 4, and then we're going to go up 2. Change in y is a +2, so we're going to go up 2. Change in x is +1. Positive is always to the right. Good. So from 4, we're going to go up 2 over 1. You're now out of room, so you can also go down 2, left 1. Those two negatives make a positive. Just make sure that you have 2 points so that you can make a line on XYZ homework. Good? Okay. They also, if you did want to find the intercepts, what you would do is y equals 2x plus 4 to find the x-intercept. You set y equal to 0. So instead of y equals 2x plus 4, you have 0 equals 2x, plus 4. Subtract 4 from both sides, you get negative 4 equals 2x. Divide both sides by 2. Negative 4 divided by 2 is a negative 2 equals x. All right, so when y is 0, x is going to be negative 2. When y is 0, x is negative 2. That's that point. That was to find your x-intercept. To find your y-intercept, we set x equal to 0. So instead of y equals 2x plus 4, we have y equals 2 times 0 plus 4. Simplify that. 2 times 0 is 0 plus 4. Y equals 4 when x equals 0. So that's the point 0, 4. And I should have explained that better here too. X is negative 2 when y is 0. That's the point negative 2, 0, right? So 0, negative 4. Oh, sorry, 0, positive 4. 0, positive 4 is right here. Those are the intercepts. If you want to use the intercepts to graph the function, you do not have to use the intercepts. Again, you can just go straight over to Desmos, erase what you had before, type in y equals to x plus 4. There it is. It should give you your intercepts, negative 2, 0, and 0, 4. Question 3, use the intercepts to sketch the graph of the function y equals 1/3 x minus 2. So I'll just use the intercepts this time. Y equals 1/3 x minus 2. To find the x-intercept, y is 0. Okay, so instead of y equals 1/3 x minus 2, we have 0 equals 1/3 x minus 2. All I've done is replaced y with 0. Now, x is being multiplied by 1/3, or you can think of it as divided by 3. And then 2 is being subtracted from it, so I want to add 2 to both sides. And now we have 2 equals 1/3 x. 1/3 x. How do I get rid of being multiplied by 1/3? We can divide by 1/3. We can also think of this as 2 equals 1x over 3. Remember how we saw that those are exactly the same? And that's actually 2 equals x divided by 3. So it's just x is being divided by 3 here. I'm going to rewrite it as 2 equals x over 3 because let's look at the scientific calculator, right? If we have one, let's say x is 6, right? 1 divided by 3 times 6 is going to be the same as 1 times 6 divided by 3. That's going to give you the same answer. So when you have the x next to the fraction, it means you're going to multiply that x by the top number and you're going to divide it by the bottom number. All right, that's what I want you to think. So how do we do the opposite of multiplying by 1 and dividing by 3? We multiply both sides by 3. Here the x is being multiplied by 1 and divided by 3. We just change it to look like that. X is being divided by 3. And then we get rid of that division by 3 by multiplying by 3. 2 times 3 is 6 is x when y is 0. So that's the point 6, 0. Good. One more. We need to find the y-intercept. You find the y-intercept by setting x equal to 0. It's generally a little bit easier. So instead of y equals 1/3 x minus 2, we have y equals 1/3 times 0 minus 2. Anything times 0 is 0. So we just have y equals 0 minus 2. So y equals -2 when x equals 0. So what are those points? Those points are 6, 0, and 0, -2, because our point is always x first and then y. We found our x was 0. Oh, sorry. We found that our x is 0 and that our y is -2. Here we found our x is 6, and we had established that our y is 0. 6, 0 is right here. 6 on our x, 0 on our y. And then when x is 0, y is -2. Can we confirm that that is true with slope-intercept form? We can, because we start at -2. -2 is where it crosses the y-intercept, or y equals. And then we're going to go up 1 over 3. Up 1 over 3. Up 1 over 3. Or you can go down 1, left 3. Down 1, left 3. And that will be our line. Again, you're welcome to check it in Desmos graphing calculator. All right, question 4. Find the slope of the line through the points 4, 1, and 5, 5. Let's graph those. 4, 1, all points are x, y. So that 4 is my x, that 1 is my y. Find x equals 4, y equals 1. Put a point right there. Then we've got our point 5, 5. My x is 5 and my y is 5. x5, y5. Connect those two. That's my graph. If they'd asked me to graph it. Oh, they do ask me to graph it. Graph the line. I also like having 3 points just so it looks better. But you don't have to, because the computer will do it for you. And you don't have to worry about your line being straight with a ruler. All right, that is my graph of the line. And what would my slope be? To find your slope, you want to pick 2 points that have a whole number for the x and a whole number for the y. For example, this point would be 3, -3, right? This point would be 4, 1, the one they already gave us, and this one is 5, 5. So find 2 of those points, and then you can either count, right? From 4, 1 to 5, 5, how do I get there? I go up 1, 2, 3, 4. So that was up 4 on the y-axis, and then on the x-axis, I went +1. Remember, slope is always change in y divided by change in x, right? Our change in y was 4. Our change in x was 1. They were both positive, so that slope is just the number 4, because 4 divided by 1 is 4. All right, you could even go, if you wanted, from 3, -3 to 5, 5. 1, 2, 3, 4, 5, 6, 7, 8. So that would be a +8. I got up to here, and then I go over 2, +2, because that was the change in y over x. 8 over 2 is, watch this, 8 divided by 2 is 4. So you can always use that to find the simplest form of your fraction. The slope is 4. How could you find the slope if you weren't able to just count, because it was a really big number, you didn't want to make a mistake, right? What is the slope formula? The slope formula is m equals y2, I don't want to put the 2 up there, y2 minus y1 over x2 minus x1, right? Now you just decide between the points they gave you. What points did they give us? I'm going to move it down here so that they gave us the point 4, 1, And then they gave us the 0.55. Because this is a new method, I'm going to get everything else out of the way so we can kind of think about it as an equation instead of thinking about it as a picture, okay? So for this one, we need a y2, a y1, and an x2, and an x1. What do those mean? It just means this is my x and this is my y, right? And again, this is my x and this is my y. Because I have two different points, these will be the first point. So this is my first x value. This is my first y value. This will be my second x value and my second y value. So now I just replace those numbers in here. Notice there's a minus sign between each one. So if these were negative at all, you would need to include not only that negative, but also the minus sign. All right, so we'll rewrite it as substituting y2 for 5, right? Let's mark this out. This y2 is this 5. The minus I'm going to keep. The y1 is this number 1. This x2 is the 5 right next to the y2. And then x1, oh, do those look like the same color? These look like the same color. X1 is this x1. Good. Now we just transfer that. So m is y2, which was 5, minus y1, which is 1, divided by x2, which was 5, minus x1, which was 4. 5 minus 1 is 4, and then 5 minus 4 is 1. 4 over 1 is 4, which is our slope. Now they want us to find the slope of the line through the points -4, 3, and 2, -5. Same thing. So -4 on the x, we'll call this x1, y1, x2, y2. -4, +3, and the point 2, -5. All right, so if they asked you to graph it, you would just draw a line between those 2 points. Right? And then they want us to find the slope. So let's use the slope formula. M is y2 minus y1 divided by x2 minus x1. Good. Y2 is -5. Keep that minus. And then y1 is 3. X2 was a +2 minus -4. Good. -5 minus 3 divided by 2 minus -4 is -8 divided by 2 minus -4 becomes 2 plus 4. So that's -8 over 6. I can simplify -8 over 6, right? Because that is -2 times 2 times 2, and 6 is 2 times 3. And then I will cancel anything that is a common factor of both the numerator and the denominator. -2 times 2 is a -4 over 3. So my slope here is -4/3. Remember that a negative slope always goes down. This is our first example of a negative slope we've seen. Here we have a positive slope, so that means from left to right, like you're reading a book, it's going up, right? This one was going up, so that's a positive slope, positive slope, positive slope. And here is our first negative slope. So it makes sense that the slope number is negative and that the line is going down. So that checks out. Now let's check. If I was to start here and I went down 4, 1, 2, 3, 4, over 3, 1, 2, 3. Yes. right? I'm still on the line. Or here I could go up 4. 1, 2, 3, 4. And then I would go negative on the x-axis. 1, 2, 3. Yes, I'm on that line. Okay, so that would be negative 4/3. You can also count. So just starting from here to get to here, remember it's always change in y over change in x. To get from here to here on y, how much did I have to change? From 3 to negative 5? 1, 2, 3, 4, 5, 6, 7, 8, negative 8. Change in x, to get from negative 4 to 2, how much did I have to change? 1, 2, 3, 4, 5, 6. Negative 8/6 is what we had over here, which simplifies to negative 4/3. Again, if you have negative 8/6 and you think that, oh, okay, I'm going to put that in as my answer, you can always go over to Desmos. Negative 8 divided by 6. Remember, press this button, convert to fraction, and I'm going to, instead of writing negative 8/6, I'm going to write negative 4/3 because that's the simplest form. All right, number 6. Find the slope of the line in the graph. You just want to find points that are definitely whole numbers, okay? It looks like this one is the point 1, 0, right? Because I went 1 on the x, 0 on the y. It looks like this is the point 2 on the x, 1 on the y. Looks like this is the point 0 on the x, negative 1 on the y. All right, so they want you to find the slope of the line of the graph. You can just count it if you want. First, I would look at it. Is it going like this? That's a positive slope. Or is it going like this? That's a negative slope. All right, so what is the slope? The slope is going to be a positive number because it's going up, right? And then if I want to get from this point to this point, I go, what is the change in y divided by the change in x? So to get from here to here, I went up 1. And then I went positive 1 on the x. 1 over 1 is just 1, so my slope is a positive 1. Okay. You're also welcome to use the slope formula. M equals y minus y divided by x minus x, right? So we'll say this is my x1, y1 are the 2 and the 1. And then this will be my x2, y2, the 0 and the negative 2. So my x2 is negative 1. Or sorry, my y2 is negative 1. My y1 is 1 with that minus sign between them. So this is this one. This is this one with the minus sign still between them. And then my x was 0. Keep that minus sign between them. And then my other x is 2. Good. Negative 1 minus 1 is negative 2. And then 0 minus 2 is negative 2. Negative 2 divided by negative 2 is going to equal 1. Why? Because a negative divided by a negative definitely becomes a positive. Two negatives make a positive, and anything divided by itself is 1. So my final answer is that slope is a slope of 1. Up 1 over 1, up 1 over 1, up 1 over 1. If it was going the opposite direction, down 1 over 1, down 1 over 1, down 1 over 1, that would be a slope of -1. All right, question 7, find the slope of the line of the graph. Again, make sure your points are whole numbers. So this one's going to be x is equal to 0, y is equal to 1. This one's going to be x is 1, y is 0. And then this one will be x is 2, y is -1. Got it? All right, so if we were to use the formula, we could say that this is my x1, y1, x1 is 0, y1 is 1. Then this can be my x2, y2. x2 is 2, y2 is -1. M is y2 minus y1 divided by x2 minus x1. -1 minus 1 divided by 2 minus 0. -2 divided by 2. 2 divided by 2 is going to be 1, but a negative divided by a positive is a negative. So our answer is the slope is -1. You can also just look at it as from here to here, I went down 1 on y, positive 1 on x. Negative on the y, positive on the x. Negative on the y, positive on the x. Or positive on the y, negative on the x. Positive on the y, negative on the x. Positive on the y, negative on the x. Or negative on the y, positive on the x, either one of those. 1 divided by -1 is -1, and -1 divided by 1 is -1. Here's question 8. Find the slope of the line of the graph. We can look at this like it is a line that can be solved. Here we have the point x is 0, y is -2. And then over here we have the point x is 5, y is -2. And so we can graph those if we want. That can be x1, y1, x2, y2. M is y2 minus y1 divided by x2 minus x1. -2 minus -2 divided by 5 minus 0, right? 5 minus 0. -2 minus -2 over 5 minus 0. Those two negatives make a positive, so it's -2 plus 2 over 5 minus 0 is just 5. -2 plus 2 is 0. 0 divided by 5. What happens when we take 0 and we divide it by a number? 0 divided by 5. 0. So our slope is 0. Even if it was 0 divided by 10, still be 0. 0 divided by -4, still 0. Good. So that is a slope of 0. We do not say it's no slope. That is a slope of 0 because it's not going positively, right? And it's not going negative in the negative direction. It's just staying flat. It's staying at a change of 0. It never goes up the y-axis and it never goes down on the y-axis. It just stays at 0. There is 0 change from left to right. So that's a slope of 0. Also, you can think of slope man, right? That's a positive slope. That's a negative slope. That's a 0 slope. And then That's the undefined slope. Sorry, I'll do this again. Slope man. This is a zero slope. This is an undefined slope. This is a positive slope, and that's a negative slope. But anytime you see flat, think 0, like this number. Anytime you think up and straight up and down, think of undefined. Undefined means no slope. So here we can say it's undefined because it's straight up and down. We can also take some points off of it. Here is the point, -3, 1. Here is the point, -3, -6, right? We'll say that's x1, y1, x2, y2. Slope is y2 minus y1 divided by x2 minus x1. My y2 is -6. My minus, my y1 is 1. x2 is -3 minus x1 is -3. Good. So I have -6 minus 1 over -3 minus -3. -6 minus 1, we're just combining two negatives, so we get a bigger negative, so it becomes -7. -3 minus -3 is the same as -3 plus 3, because those two negatives make a positive. -7 divided by 0, because -3 plus 3 makes 0. Remember what happens if you divide. So you can divide a 0 by a number, but what if you take that number and you divide it by 0? We get undefined. You cannot take a number and divide it by 0. So that's why we say that the undefined straight up and down line has no slope. Slope of -7 over 0. All right, for the following line, name the slope and y-intercept and write an equation of the line in slope-intercept form. Find 2 points that look like whole numbers. This one looks like the number 0.0, -3. So 0 and -3 are both whole numbers, okay? I'm not going to pick this where it's crossing -1x because it's not a good point for y, right? The y would be like -2.5. Here, it looks like we have an x of -2, y of -2, right? Here, it looks like we have an x of -4, y of -1. X of -4, y of -1, right? Those look like real points on this graph, and so did this one. So you can choose any of these as your point. I just picked these two, okay? To find the slope, y2 minus y1 divided by x2 minus x1. So let's label these. This will be, does not matter where I start. This will be x1, y1. This will be x2, y2. Good. So my y2 is -3. Keep that minus sign. My y1 is -1. See how I have 3 minuses now? I have the -3 and the -1 and the minus sign from the equation. And then x2 was 0. Keep that minus sign. Sorry, keep that minus sign. And then x1 was a -4. -3 minus -1 is -3 plus 1. 0 minus -4 is 0 plus 4. So we took those double negatives and made them positive. -3 plus 1 is a -2. 0 plus 4 is 4. -2/4 is our slope, but we can simplify that to -1/2, right? Why? Because 2 is a factor of 4. So if I have -2 divided by 4, I can change that to -1 times 2 divided by 2 times 2. And then I can cancel those and I'm left with -1/2. All right, so my slope is -1/2. Does that track? If I start here, if I go down 1 on x, sorry, on y, and +2 on x, down 1 on y, right 2 on x, I get to the next point. So my slope is -1/2. My y-intercept, right? They gave you this line. So your y-intercept is where it crosses this line. My y-intercept is -3. They give you the 0 for the x, so you just put in the y value of -3, and then that equation, remember we're thinking of y equals mx plus b, where b is the y-intercept, and where m is the slope, including the sign of the slope. Oh, sorry, you couldn't see any of that. Slope is -1/2. Y-intercept is -3. Right? They already gave you the 0 for the x. You just put in the -3. Now we think of the equation in y equals mx plus b form, which is also called slope-intercept form. And we think y equals m. They want us to put in the slope, including the negative, the letter x, plus, and then the y-intercept, including the negative for the b. Okay? So that all becomes y equals -1/2 x plus -3, which I will rewrite as y equals -1/2 x minus 3. Good? All right. Find the slope of a line parallel and perpendicular to the line 5x plus 4y equals -1. All right, 5x plus 4y equals -1. What do we know about parallel and perpendicular lines? Parallel line has the same slope. All right, so the parallel line will have the same slope, and then the perpendicular line will have the negative reciprocal slope. Same slope, negative reciprocal slope to this line, 5x plus 4y equals -1. So to find the parallel slope and the perpendicular slope of this line, we need to first find the slope of that line. If you want to graph it, you can do that to find the slope. What I would do is I would change it from standard form, which is what it is in, 5x plus 4y equals -1. I would change it to slope intercept form, what they were asking us about for this one, right? Y equals mx plus b, because then whatever is next to the x is going to be my slope, okay? So I'm going to solve this for y, meaning I'm going to move over the 5x and I'm going to divide everything by 4. Subtract 5x. I'm not putting it under the -1 because those are not like terms. So now I have 4y equals -5x minus 1. Now y is being multiplied by 4. I want to get rid of that, so I divide everything by 4. Good. That cancels, and I have y equals -5/4 x minus 1/4. Okay, they're not asking you to graph this, so don't worry about that y-intercept not being a whole number. All they're asking you to do is find the parallel slope, the same slope, and the negative reciprocal slope, okay? So the slope of the line, the slope of 5x plus 4y equals -1 is -5/4. Let's check that, okay? Because that's what I've just decided by doing this math right here. Is it negative 5/4? I'm going to graph it and look at what it looks like on the graph. 5x plus, no, 4y equals -1. Good. Is that a slope of -5/4? Is that equal to y equals -5/4 x minus 1/4? That looks like the same line, right? So when I solved it to say y equals -5/4 x plus minus 1/4, I got the same line because that black line is covering that purple line. So that's a good sign. Now, let's see if we can find some points on this line. Three, -4. Yeah. And -5, 6. -5, 6, and 3, -4 both look like they're on the line, right? All right, if I go down 5 and over 4, ooh, what's that one? -1, 1. All right, so remember, the slope of -5/4 means that from this point, -5, 6, I'm going to go down 5, and then I'm going to go right 4. From -1, 1, I'm going to go down 5, right 4. Yeah, and get to another whole number. So that does look correct. Okay. Now we've found that slope. The parallel slope is going to be that exact same slope, -5/4. Right? Because the slope of this line is -5/4. The slope of a parallel line is -5/4. Parallel just means that they're exactly the same, right? So if I said, oh, yeah, okay. So those two are parallel because they have the same slope, right? Y equals -5/4 x plus 2. I'm gonna write they're both black. Those are all parallel because they all have the same slope of -5 divided by 4. Same slope, all right? Perpendicular slope is going to be the negative reciprocal. The negative reciprocal of that slope. Y equals -5/4 x. All right? Y equals -5/4 x plus 4 plus 5. All right, those have the same slope. Those are parallel. What is the negative reciprocal? Negative means the opposite, right? So if that's a negative number, the reciprocal is going to be a positive number. Or sorry, the opposite is going to be a positive number. And then reciprocal means you take whatever's at the bottom of the fraction and put it on the top of the fraction. You see how that's a reciprocal? We had -5/4. Now we have, instead of 5/4, we have 4/5, which is the reciprocal. And then instead of a negative, we have a positive, which is the opposite. So if you're trying to find the perpendicular line, you take whatever your slope is, you flip the top and the bottom of the fraction, and you change it from a negative to a positive or from a positive to a negative? Parallel is -5/4. What's on the bottom here is a 4, so I'm going to put it on the top for the perpendicular. What's on the top, I'm going to put it on the bottom, and then if it's a negative, I'm going to keep it the opposite, okay? Opposite reciprocal slope or negative reciprocal slope. The negative of a negative is a positive. Reciprocal of 5/4 is 4/5. Find the slope of any line parallel to the line through 1, 1 and -4, 3. So you just need to find the slope of 1, 1 and -4, 3. x1, y1, x2, y2. Slope is y2 minus y1 divided by x2 minus x1. 3 minus 1 divided by -4 minus 1. 3 minus 1 is 2. -4 minus 1, you're combining negatives, so you get you're adding them, but it's still a bigger negative, -5. So that's -2/5 as my slope. A parallel line to -2/5 is also going to have the slope of -2/5. You do not change anything for the parallel. Parallel, parallel, right? There's no change. You don't change anything. If you were asking for the perpendicular, then you would flip it and make it positive. But they're not, they're just asking for parallel, the same. Question 13, find the slope of any line perpendicular to the line through -6, 5 and -3, 2. Again, let's find the slope. x1, y1, x2, y2. So the slope is y minus y, x minus x, 2 minus 5 divided by -3 minus -6, -3, -3 plus 6, -3 over 3 is -1, right? The slope is -1. And if you were to graph that, you would be able to see -6, 5, -3, 2. One, 2, 3. So we went down 3. 1, 2, 3. Down 3, right 3, down 3, right 3. Down 1, right 1, down 1, right 1, down 1, right. And you'll get there. Good. So the slope is -1, but perpendicular. So we need to find something perpendicular to -1. And because we're going to do the opposite reciprocal, we're going to want to put it in fraction form. -1 is just -1/1. So it's negative, it's going to become positive, right? Because that's opposite. And then 1/1, still just 1/1. So the slope is -1. That was a hard one. All right. Graph the line that has an x-intercept of 3. X-intercept means it crosses this line at 3 and a y-intercept of -3. What is the slope of the line? So graph it just means put a line right there, right? You have 2 points, you draw a line, that's your graph. Now, to find the slope, we're going to say that this is the point 3, 0, right? And this is the point 0, -3. And then we're just going to either, you can go 1, 2, 3, plus 3 on the y. 1, 2, 3 plus 3 on the x. So that will be 3y, where 3x is 1. Or you can do y minus y over x minus x, which gives you, right? That gives you negative 3 minus 0 divided by 0 minus 3. That's just negative 3 over negative 3, which is 1. Right? So our slope is 1. Question 15 asks us to give the slope and y-intercept of this equation and sketch the graph. Give the slope of any line perpendicular to the given graph line. Remember, perpendicular means do not change anything. The same slope, perpendicular. Good. 5x minus 3y equals negative 15. If I was to find the slope and y-intercept, I would just move this over to slope-intercept form, right? 5x minus 3y equals negative 15. I want y alone. Right now it's being multiplied by a negative 3 and 5x is being added to it. So I'm going to subtract 5x. Negative 3y equals negative 5x minus 15. Divide everything by negative 3. Right? Y equals negative divided by negative is a positive 5/3 x. Negative 15 divided by negative 3 is a positive 5. Good. And remember, you can put stuff like that into Desmos. So if you want to go back to the scientific calculator, you can say negative 5/3. Sorry, negative 5 divided by negative 3 is a positive 5/3. Doesn't matter if you write it like that or you write it like, it's still a positive, right? And then negative 15 divided by negative 3 will also give you the simplest form of that answer, which is a whole number of positive 5. All right, so remember to use Desmos when you need it. The slope then, right? Now we have it in y equals mx plus b, where m is the slope and b is the y-intercept. So that's just going to go right here. It's a positive 5, and the slope is positive 5/3. Good. Sketch the graph. It's going to cross at y equals 5. And then the slope is going to go up 5/3, up 5/3. That's going to be difficult, right? Because we're already at 5. We go up 5, it's not on the graph. Remember that 5/3 is the same as negative 5/3, right? Let me show you that. Negative 5, negative 3 is a positive 5/3, okay? We're going to use that right now to say down 5, 1, 2, 3, 4, 5. Left 3, 1, 2, 3. 2 negatives, because we went negative y direction, negative x direction, still makes a positive line, a positive slope. Because we took both sides negative, and a negative divided by a negative makes a positive. So that's the graph, right? And then slope of a perpendicular line is the same slope. Good. All right, the slope and 1 point on the line are given. Find the equation of the line in slope-intercept form. Here, you want to have ready your point slope form, right? So they're asking you for the equation in slope-intercept form, which is y equals mx plus b, the one we've been talking about today, previously. But if you have a point, we're just going to label it x1, y1 like we've been doing with our other points. Point slope form is y minus y1 equals x minus x1, but that's all being multiplied by the slope. Okay, so we have the slope, we have x1, and we have y1, right? I'm going to write it the other way. Y minus y1 equals m times x minus x1. Good, and then we're going to take what they've given us. Our m is 3, so we're going to switch that to 3. Y1 is 0. Keep that minus sign between them. And then x1 is -4. Good. So you want to have this memorized. Y minus y1 equals m times x minus x1. And then you're just going to substitute in. You're going to label x and y. And then you're going to substitute it in. So y minus y1 we said was 0 equals m, which they said was 3, times x minus -4. And then just solve it. Okay. Y minus 0 leaves us with y on the left. 3 times x minus -4 is going to be +4. Distribute that 3, okay? Y equals 3x plus 12. Find the equation of the line. Y equals 3x plus 12. Don't put the y again because they already added it for you. All right, 17. The slope and one point on the line are given. Find the equation in slope-intercept form. Again, we're just going to go from y minus y1 equals m x minus x1. We're going to go from that form to y equals mx plus b form, okay? This is my x1. This is my y1. This is my m. So I'm going to replace those, okay? Y minus -4 equals -3 times x minus -5. Good. Y minus -4 becomes y plus 4. -3. X minus -5 becomes x plus 5. Y plus 4 equals -3x plus 15. You're not done yet because y isn't alone. We need to subtract 4 from both sides. I'll put it under the 15 because those are like terms. So I get y equals -3x plus 11. Good? All right. Use 2 points on the graph to find an equation of the line in standard form. I'm not going to do this one because there's no standard form on the actual exam. Don't like standard form. Question 19, I'm also going to skip because it's about standard form. All right, now we are moving on to functions. For the following relation, give the domain and range and indicate whether it is a function. Remember that a function is a relation is a function when each x has only one y value. Each input has only one output. You're going to the grocery store and the milk is the same price every time. Okay? The milk and the eggs might be the same price. So the y's can be different, or the y's can be the same, but the milk should always have the same price, right? So domain are your x values, your input, domain, input, x value, okay? My domains are 4, 5, 7, and 1. My ranges are my y values. 2, 4, 5, and 7. I don't think anything is repeating, right? 4, 2, 5, 4, 7, 5, 1, 7. So we don't have any repeating x values or any repeating y values. So is it a function? Yes. What would be the domain in the range of 4, 4, 9, 7, 9, 8, 7, 1? Okay. Here we are having, here's a different relation, right? The domain could be 4, the domain could be 9, or the domain could be 7. Notice I did not write 9 twice because they only gave me 3 spots for the domain. You don't need to repeat it, even though it is repeating. Okay, 9 is paired sometimes with 7, 9 is paired sometimes with 8, right? I go to the grocery store, I buy a 9, sometimes the 9 costs 7, sometimes the 9 costs 8. My range, 4, 7, 8, and 1. Is this a function? No. 9 is sometimes with 7 and sometimes with 8. That is illegal when 9 is a domain, right? The domain has 2 different possible ranges, not allowed. The graph of the relation x minus 3 quantity squared plus y plus 3 quantity squared equals 9 is below. Use the graph to find the domain and range using interval notation. Okay. Remember, domain, you can relate it to over here. Domain were my x values. Range were my y values. Right? My x values, my y values. So here my domain is still going to be my x values. And here my range is still going to be my y values. Whoops, values. What is the domain and range of a shape? It's just how far, where. Where is it on the x axis? Okay. Where does it start? Where does it end? Here, right? According to x, it's starting right here and it ends right here. So my domain is it starts at, we're only looking at the x values, right? This is x equals 0. And here is x equals 6. Right? It goes from 0 to 6. Domain is 0 to 6. Is it touching 6? Yes, it is. If it wasn't touching 6, if it had a pull like that, right? Then it would be parentheses. It's touching 6, so we're going to use brackets. Is it touching the 0? Yeah, so we're going to use brackets. Same exact thing with the range. What are the y values? Where is it on the y-axis? Okay. It starts way down here on the y-axis. What is the lowest point on the y-axis? What is the highest point of this graph on the y-axis? Okay, it's another way. Lowest point to highest point. What is the lowest point? It's x equals 0. What's the highest point on the x-axis? It's x equals 6, so it's from 0 to 6. Down here, what is the lowest point? Y equals -6. What is the highest point this graph reaches? Y equals 0. Does that make sense? So from -6 to 0 is the range. From 0 to +6 is the domain. Is it a function? It is not a function. Because remember, you should be able to take a vertical line and draw it anywhere on that function and only cross one time. Here we're crossing twice, so it does not pass the vertical line test. So it's not a function, okay? 23, the graph of the relation x equals y squared plus 1 is below. What are the domain and range using interval notation? The domain is all x values. Where does it start on x? It starts, it's not a ruler. It starts right here at x equals 1. Where does it stop? Does it stop here or does it keep going forever? It keeps going forever. I mean, it ends at infinity. Infinity always gets the parentheses, but you can see that it's touching x equals 1, so that's getting brackets. So the domain is 1 to infinity. Good. Now we're doing the exact same thing for the y-axis. All y values. So when we're coming down here, where does it start? Does it start right here at negative 2.8? No, because we know that that goes on forever. So it starts at negative infinity and it goes until infinity. It's going from the very bottom of the graph all the way up forever, okay? So you just put those into parentheses and you get range is negative infinity to infinity. Infinity always gets parentheses. That is our range because it's every y value is going up and down forever. X, it starts at 1 and then it goes forever. Starts at 1, goes forever. But on the y, it starts way down here, it goes up there forever. Good. Is it a function? No. It does not pass that vertical line test. I can put a line right here and it'll go through that point, sorry, that function 2 times, that non-function. Here is y equals x squared minus 4. What is the domain and range using inequality notation? Ooh, inequality notation is not interval notation. Inequality notation is x is less than 3. Good? Okay. So remember, domain is all x values. And the range is all y values. Okay, so on the x-axis, that is an arrow, right? So that means it goes forever in this direction. So from negative infinity to infinity on the x-axis, right? It's never going to stop because that's what that arrow means. Never going to stop, never going to stop. So again, our domain for x is from negative infinity to infinity. Unfortunately, that's not the answer in inequality notation. That's in interval notation. In inequality notation, it's just every number. So all real numbers. Okay. Remember yeah. So all real numbers, every number. Any x value is possible, okay? Range are the y values. Where does the y start? The y starts at negative 4. X is greater than or equal to negative 4, right? Because it's going to start at negative 4. It might be negative 4, and then it's every number above that, right? It goes forever, forever, forever in the y direction, all right? Is it a function? Yes, it is a function because anywhere we draw a vertical line, we will only touch the graph in one spot. Passes the vertical line test. All right, the domain and the range of the function graphed below. So the domain, remember, is all possible x values. Yeah. For x, it starts at and includes -2, and then it goes all the way to 1. It does not include 1. So because this is an open circle, we're going to use the parentheses. And then because this is a closed circle, we're going to use the brackets like we were using with situations like this, where it is touching the -4. Here it is touching the -2, but that open circle, since it's not touching the positive 1, but that it does end there. Okay. Now, for range, that's all y values. All y values, my lowest y value is 0. And remember that it says it includes 0. And then my highest is not 3, it's actually up here at 4, and it includes the 4 because it's not an open circle. So my range is going to be from and including 0 to and including +4. And then my domain is going to be from and including -2 to and not including +1. Okay. All right, question number 6 again asks us to find the domain and range of the function below. Down here it says entry example. They have a open bracket 2, 3, close parentheses, open parentheses, -infinity, 5, close parentheses. So that means they want it in interval notation. All right, remember that the domain are all possible x values. So that means we are looking along the x-axis, okay? Where does it start? Remember, you should start with the smallest number. So where does it start on the x-axis? And where does it end? You see that this is an arrow, so you're going to see that I automatically think it goes on through infinity if you see an arrow, okay? So x is, it starts at -1x, and it goes on to infinity. So comma infinity. Infinity always has the parentheses, never the bracket. And then for -1, because that is hollow, that does not include -1. So not include is the parentheses, not the bracket. For range, all possible y values. Y values are up and down. So what of these are contained in this graph? Okay, start at the bottom. The lowest point is right here at -5. So the range is going to start at -5. It's a filled in circle, so I'm going to make it a bracket. It includes -5. And then where does it go? You might think, okay, it goes up to 4 because that's where it stops. So that would be 4 and it would include 4. However, remember this arrow. This arrow means this line is going to go forever in this fashion. It's going to go above the 4. So we're going to say to infinity. Often if you have arrows, it means that you're going to be using infinity at least once. Okay, maybe all 4, right? If you have something like this with an arrow going down and up, that's infinity to infinity. And because it's going from left to right, it's infinity, -infinity to infinity. So that would be -infinity to infinity, -infinity to infinity. Because the arrows are going both directions, that means it goes every direction forever. All right, now we're moving on to solving functions and composite functions. Evaluate f of -2, f of 2, and f of 0 for the following function. Our function is f of x equals 3 times the quantity x minus 2 squared minus 4. Now this looks quite exotic, but really all we're doing is we're practicing solving this, okay? We're just going to put in -2 for x, 2 for x, and 0 for x. If you know how to do algebra, you'll be fine at this. It's just algebra practice. All right, so for all of these, we have the equation for the function f of x equals 3x minus 2 quantity squared minus 4. So this is being squared, then it's being multiplied by 3, and then we're going to subtract 4 from it. Think about how to solve this, okay? If this was just algebra, how would you solve x minus 2 squared? You would go, we would expand it, right? You don't really have to because we're putting in a number for that. And so you can put that number minus 2 and then square that number. That's also fine. But do remember how to simplify these, how to do each part of these problems because it's easy to make mistakes. And that is really all we're doing. We're just putting in that for x, and we're going to put that in it for x, and then we're going to put that in for x. All right. So A is f of x becomes f of negative 2. So instead of x, I'm going to put in a negative 2. I always put it in parentheses because when it's a negative, there are more opportunities to just miss stuff, I feel. And when you have things like the square or the cube, you need to know how far it goes, if that makes sense. All right, so now we just simplify. And again, we'll just do one of each. You can expand it like we were doing last unit to solve it, or you can say, what is negative 2 minus 2, and then square that number. You'll get the same answer. Just remember that when you have x minus 2 squared, that means we're expanding the whole thing. We're not just taking negative 2 squared. All right, so that becomes 3. Negative 2 minus 2, you're just combining two negatives, so you're going to get an even bigger negative. So 3 times negative 4 squared minus 4, or over here it would be 3 times negative 2 minus 2 is a negative 4. Negative 2 minus negative 2 is another negative 4 minus 4. Do you see how that negative 4 squared is now negative 4 times itself? Those are the same, right? Now, what is negative 4 squared? Negative times a negative is a positive, so it's not going to be a negative number, and 4 times 4 is 16. So 3 times 16 minus 4, over here we should get the same. 3 times negative 4 times negative 4 is 16, negative 4. So now we have the same, right? Doesn't matter which way we did it. 16 times 3. If you don't have a calculator, it's very easy. Just go over to Desmos. 3 times 16. Sorry, my screen's too big. Is 48. So now we have 48 minus 4. I guess I don't need to keep writing them, right? Because they're the same. 48 minus 4 is just going to be 44. So f to the negative, or sorry, f of negative 2 is 44. Let's do b, f of 2. So exact same process, but instead of a negative 2, we're going to use a positive 2 to substitute in for x. F of x is 3 times x minus 2 squared minus 4. So f of positive 2 is just 3 times positive 2 minus 2 squared minus 4. Good. Inside the parentheses, we have 2 minus 2, which is 0. 0 squared just means 0 times 0, right? 3 times 0 minus 4. And then again, 0 times 3 is 0. So we have 0 minus 4. So our final answer is f of 2 is 4. And the last one is, we'll call it C, f of 0. If f of x is 3 times the quantity x minus 2 squared minus 4, then f of 0 is going to be 3 0 minus 2 squared minus 4. F of 0 is 3 times 0 minus 2 is going to give us a negative 2 squared minus 4. Negative 2 squared is positive 4. Negative times the negative becomes a positive. 2 times 2 is 4 minus 4. 3 times 4 is 12 minus 4, which is 8. So f of 0 is 8. We thought f of 0 would be the easy one, but f of 2 was kind of easier than f of 0. All right, now they're asking us to match each graph with its equation. We have f of x equals x squared minus 2, f of x equals the absolute value of x minus 2, f of x equals the square root of x minus 2, and f of x equals x cubed minus 2. Think about the parent graph of each of these, okay? X squared is always going to be that parabola. The absolute value of x is always going to be to a v, an upward v. The square root of x, remember, just kind of goes like that off into the distance forever because you can't have a negative. And then x cubed is a little bit like x squared, but there's a little turn in it, right? Instead of going up on both sides, it's like they flip this one down a little bit. So you go for x cubed. And that's really all you need to know. All you need to know are the parent functions of x squared, square root of x, absolute value of x, and x cubed, because that's what's different about each of these graphs. They all have minus 2, but minus 2 just means we're going to start at y equals negative 2. Y equals negative 2 instead of y equals 0 or the origin, okay? This one looks like x squared, right? This one looks like x cubed. This one looks like square root of x. And this one looks like the absolute value of x. To check your answers, you can graph them. So it was f of x equals x squared minus 2. Absolute value of x minus 2. Square root of x minus 2. And x cubed minus 2, right? So you can see the red one is the first graph. The purple one is kind of hard to see, but the purple one is that second graph. The green one, easier to see. The green one is that third graph, and the blue one is that fourth graph. So you would just be matching those. All right, the equation of the red curve is y equals negative 2x. Find the equation of the blue curve. So what is the difference between the red curve and the blue curve? The red curve is lower, right? So we know from the last question that a parabola like that is x squared, right? What's the difference between this parabola and the red curve is it's going down. Instead of going up, positive x squared, it's going down. So we're going to make the whole thing a negative. Negative x squared is the red curve. Is that true? Yes, y equals negative x squared. So that follows what we know about what this graph's supposed to look like, right? And then if we look at each of these, right, what did we say subtracting 2 did? We said subtracting 2 outside of the x brought it down from the origin down to on the x. right? That went down 2. Instead of starting here, it started here. It went down 2. Here to here, down 2. Here to here, down 2. So if we subtract 2, it goes down on the x-axis, right? So we had the red one. It's at the origin, right? Because a parent function starts at the origin. This went up 1, right? Up 1 on the y-axis. So we go from y equals negative x squared to, that's the red one, y equals negative x squared plus 1. Let's check that in Desmos, okay? So we're just going to start with the graph x squared. And we're going to make it exist. It's red. Good. Instead of starting at the origin, oops, sorry, negative x squared, because it should be going down. And instead of starting it at the origin, they want us to start it up here at 1. So we think negative x squared minus 1. Nope, not minus 1. That'll move it down. How about plus 1? That'll move it up. So I'm going to say that the equation of the blue curve is y equals negative x squared plus 1. Okay. Now we have the equation of the red curve is y equals negative absolute value of x. Find the equation of the blue curve. Again, it's pretty similar, right? That one was at the origin. We added 1 because it moved 1 above the origin. So if y equals negative absolute value of x, y equals negative absolute value of x plus 1 to make it 1 higher. And you are welcome to check that on Desmos if you would like. All right, sketch the basic graph of the function of the given function and the graph of the given function on the same axis. So the basic graph is the parent function. Basic graph is going to be f of x equals x squared. Okay, let's make a table of xy values or xfx value for this. Okay, if x is 0, 0 squared is just going to give us 0. If x is 1, 1 squared is going to give us 1. If it's negative 1, negative 1 squared is going to give us a positive 1. If it is 2, 2 squared is going to give us a 4. And negative 2 is going to give us a positive 4 as well. Do we agree? So I just substituted in an x value. If it's 0, y is 0. If x is 1, y is 1. If x is negative 1, y is 1. If x is positive 2, y is 4. And if x is negative 2, y is again 4. And y is just f of x, right? Because if y equals x squared is a function, then we can replace y with f of x. So I was using those interchangeably. All right, let's graph this. So we have the point 0, 0. We have the point 1, 1. We have the point negative 1, 1. And the point 2, 4. And then the point negative 2, 4. So that will be the basic graph. Start here. 1, 1. Negative 1, 1. Positive 2, positive 4, and then negative 2, positive 4. That's your parabola. Good. And then x squared minus 4. We know if the minus is outside of those parentheses, right? That means a vertical translation down 4 units. So instead of starting here, we're going to start here. I take that next point, it's at 1, 1. I'm going to make it down, count it down. Down 1, 2, 3, 4. Same on this side. 1, 2, 3, 4. This is at 2, 4, so it'll just go straight down to the x-axis because we're subtracting 4 from it. And then that'll be the given function. X squared minus 4 is that one. X squared is that one. Sketch the basic graph and the graph of the given function on the same axis. Very similar, we have the square root of x, and then we have the square root of x minus 4. So f of x is equal to the square root of x. Let's make an xy table. Here's x, here's y, or f of x. When x is 0, the square root of 0 is 0. When x is 1, the square root of 1 is 1. We're not going to use negatives for this because the square root of a negative number is an imaginary number, so we're only going to use positives. The square root of 2, right, is going to be a fraction, so I'm just not even going to use 2 because I don't want to try to find a fraction on my graph, right? Can I take the square root of 3 and get a whole number? No. Can I take the square root of 4 and get a whole number? Yes. The square root of 4 is 2. Good, so those are some points I can now graph. I can graph the point 0, 0. I can graph the point 1, 1, and I can graph the point 4 on the x-axis, 2 on the y. 0, 0, 1, 1, 4, 2. So my graph looks like this. Then we've got, that's just x. That's the graph f of x equals the square root of x. Make that big so that it looks like I made it. And then for our next one, what's the transformation rule for functions? If we are subtracting d from it, we translate it vertically down that many units. So again, start at 0, 0, go down to negative 0, negative 4. Starting at 1, 1, go down to 1, negative 3. Starting at 4, 2, go down to 4, negative 2. And that is my given function, f of x equals the square root of x minus 4. So it'll look the same, it's just moved down. Good? All right, here we've got some composite functions. If f of x equals x squared and g of x equals x minus 1, let's find f of g of x. I like to rewrite f of g of x like this. F of g of x. Okay, so what they're asking is, what is g of x? And then whatever that value is, put that in for the x in f. All right, so that means f of g of x, I don't think I needed to rewrite that, is f of x is just x squared. So instead of that x, we're going to put in x minus 1. So instead of x squared, we have x minus 1 squared. Okay. They do not want you to leave it as x minus 1 quantity squared, so we're going to expand it. X minus 1, squared becomes x minus 1 times x minus 1. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is minus x. Negative 1 times negative 1 is a positive 1. So that's x squared minus 2x plus 1 is our final answer. Okay, so don't leave it in its factored form. Factor it out. This now is kind of the opposite, g of f of x. Again, I like to write it as g of f of x because you want to start on the inside and work your way out. So that becomes g of x is x minus 1. So instead of that x, we're going to put in f of x, which is x squared. X squared minus 1. Well, that's all we can do. X squared minus 1. All right, and after that we have f of g of 3. There are two different ways to do f of g of 3. Notice that this f of g is the same f of g from part A. So we know that f of g of x is equal to x squared minus 2x plus 1. So one thing you can do is you can simply replace that 3, replace the x here and the x here with a 3. So f of g of x we know is equal to x squared minus 2x plus 1. So f of g of 3 is going to be equal to 3 squared minus 2 times 3 plus 1. And then that simplifies 3 times 3. 3 times itself is 9. Negative 2 times 3 is a negative 6 plus 1. 9 minus 6 is 3. Plus 1 is 4. Good. Or if you have not found out what f of g is as an equation yet, you can simply work from the inside out. So this will be the same f of g of 3. F of g of 3. You start here and you work on the innermost problem first. So that's why I like putting it in this format instead of f symbol g, close the parentheses, parentheses 3. You can see what's inside if you write it like this. So first we need to find what is g of 3. We change colors because it's kind of close to that other example. If we go back up to the top, it says g of x is x minus 1. G of x is equal to x minus 1. So therefore, g of 3 is just going to be 3 minus 1 because we're replacing that x with a 3. 3 minus 1 is 2. So g of 3 is equal to 2. Good. So instead of f of g of 3, we now have f of 2 because g of 3 is 2. So we replaced g of 3 with 2 because we determined that g of 3 is equal to 2. So that's just going to be replaced. G of 3 is going to replace by 2. So we're going to say that f of x, and we go back up here to the top, f of x is equal to x squared. So f of, what do we have? 2 is just 2 squared, which is 4, which is the same answer we got when we used the equation from part A. So either one of those methods will work to find f of g of 3. Good. Now, same sort of idea where we have g of f of 3, right? So you can just put the 3 in right here because that's g of f, the same as that g of f. So we'll replace the x with a 3, or you can do the work yourself if you would like. We'll pull some, give us some space. G of f of 3. G of f of 3. Again, I write it this way so that you can see what goes inside or what is first. F of 3 is f of x equals x squared. F of x equals x squared. So f of 3 is going to be 3 squared. 3 squared is just 3 times 3. So f of 3 is 9. Now we're going to replace f of 3 with 9. G of f of 3 becomes g of 9. We look at what g is. G is x. G of x is x minus 1. Just like up here, f of x is x squared. G of x is x minus 1. So g of 9 is going to be 9 minus 1, which is 8. Good. So here we have 8. And again, we said that instead of doing it by finding and by solving f of 3 and then putting that into g, we could also just take 3 and put it into the equation we already found, because g of f, x becomes 3. 3 squared is 9. 9 minus 1 is 8. So you get that same answer. All right. Is that everything? Okay. Now we've got, for the following exercise, given the function f, evaluate f of -1, f of 0, f of 2, and f of 4. Notice the formatting, okay? It's the same formatting as before, so we have done this, right? It's not, it looks a little bit like this, but what does it look more like? It looks more like this one, right? Evaluate f of -2, f of 2, and f of 0 for the following function. So what we did here for number 27 was f of x equals 3 times the quantity x minus 2 squared minus 4. F of -2, we put in a -2 right here, right? F of +2, we put in a +2 right here. F of 0, we put in a 0 right here, right? But we use the same function for each example. Here, same thing, right? What is f of -1? What is f of 0? Just like that f of 0, right? That f of 2, f of 4, right? So same idea, same principle, but instead of f of x equals 3 times the quantity x minus 2 squared minus 4, we have several options, okay? I'm going to write that out a little bit differently. Here it says f of x equals 2x when x is less than 0. So f of x is 2x if we're talking about a number less than 0. X is a number less than 0, right? F of x is just 5. There's not even an x to substitute. It's just always 5. When x is between 0 and +3. Okay? And then our last one, f of x is x squared when x is a number bigger than 3. That is all that is saying. Okay, it looks confusing, but we can interpret it. F of x is just the number 5 if we're talking about x being between 0 and 3. Okay. F of x is 2x if we're talking about a negative number, a number less than 0. F of x is x squared if it's bigger than 3, right? So think of a number line, right? Here is 0, okay? If it's less than 0, we're talking about this. All of this is a number is less than 0, all right? When x is between 0 and 3, and that's including 0 and 3, right? Because those are the equal signs. Then we're talking about f of x is 5. And anything bigger than 3, we're talking about f of x is x squared, okay? Down here, we're talking about f of x is 2x. So we're just making 3 different categories, right? On the number line, we've got this whole category for if it's less than 1. Or sorry, less than 0, I apologize. we have this whole category for if it's between 0 and 3. And then we've got this category for any number bigger than 3. Okay, so each one has their own equation. Start by deciding what -1 is. -1 is this group right here, right? Because -1 is less than 0. F of 0 is between 0 and 3. Good. F of 2 is right here, so that's also between 0 and 3. And F of 4 is more than 3. So we've broken them into categories, right? F of -1 is this equation. F of x equals to 2x is the equation we're going to use for this one, right? Because it's between negative infinity and 0. -1 is, right? So we're going to use this equation, 2x, because x is less than 0. 2x when x is a number less than 0. Here it is on the number line, a number less than 0, right? So it takes a lot, you need a lot of planning before you just jump to this, okay? This planning is just deciding, what is this actually telling me? Do I need to write it out as a sentence in English? Do I need to draw it on the number line? How do I need to understand that before I go to this, and this, all right? F of 0, that's between 0 and 3, so that's f of x equals 5. And honestly, we're done. There's nothing to substitute. It's just 5. F of x is always 5 for all of these values. Same here. 2 is right here. F of x is 5. F of 4 is now over here. So f of x equals x squared. We're not done, but we did decide, are we using 2x, 5, or x squared for each of these terms we need to evaluate, okay? So now, f of x equals 2x is what's going to be used for f of -1. So I'm going to take that x and I'm going to substitute it for -1. So f of -1 is 2 times -1, which is -2. So that's my final answer. All right, here we've got a 2. For 0 and for 2, f of x is 5, so we're done. We just say the answer is 5. There's nowhere to substitute my x. I just say it's 5. And for our last one, f of 4 is f of x equals x squared. And I'm going to substitute that x with a 4. So instead of x squared, I have 4 squared, which is 16. And those are my answers. I know that looks really intimidating, and there are several steps before you actually start looking at and substituting in the x's, but it is manageable. It's comprehensible if you start up here and you think, I want to understand what they're saying with f of x equals 3 different terms, right? You can figure out how to use these terms because you can decide 2x. When should I use 2x? I should use 2x for x is less than 0. Which one of these is less than 0? This one's less than 0, right? Maybe I should have highlighted that better, right? When should I use 5? When it is between 0 and 3. When should I use x squared? When they're talking about a number bigger than 3, like this 4. All right, now we've got problem 35. For the following exercise, select the graph of the piecewise function, write the domain in interval notation. Those are two different things, okay? So first we're going to select the graph, and then once we've picked the graph, we're going to write the domain in interval notation because we don't need to write the domain of all 4 of the choices. We just pick one and then we write the domain, okay? So let's write it out just like we did the last one. F of x equals 3 when x is less than 0. F of x equals 3 when x is less than 0. And then f of x is the square root of x when x is, oh, sorry, we were supposed to be writing that in English. When x is less than 0, is a number less than 0. Sounds good? F of x equals the square root of x when x is greater than or bigger than or equal to 0, right? So here's my number line, here's 0. And remember, 0 is the y-axis, right? And so we're dividing it between less than 0 and right on 0 and bigger than 0, right? So those are our two categories. Over here, greater than or equal to 0, we have square root x. Less than 0, we just have the number 3, okay? What is the graph of f of x equals 3 or y equals 3, right? Y equals 3 is just no matter what, y equals 3, right? If we were to make an xy table of it, it would be y equals 3 when x is 0. Y equals 3 when x is, well, no, greater than or equal to 0. We shouldn't use that, right? -1, -2, and -3. When x is -1 for y equals 3, y is 3. When x is -2 for y equals 3, y is 3. When x is -3 for y equals 3, y is still 3, okay? No matter what our x value is, y is 3. Let's look at our 4 example graphs and make sure they all have that line, y equals 3. So that'll go through the point -1, 3. It'll go through the point -2, 3. And it'll go through the point -3, 3. Right? Here's -1, 3, -2, 3, -3, 3. Right? So that graph does show those points, right? That graph shows those points. I'm going to turn it over and look at the other two examples. -1, -2, and -3. That one's okay. But look, down here, they've gone to -3. Nope, because it should be that point, and that point should all be on the graph, right? Because those are the points. -1, 3, -2, 3, and -3, 3 that we found from our table of y equals 3. So because those aren't there, we're going to say this is not the right answer. All right, so we've eliminated one. We just have to decide, is it this guy, this graph? Is it this graph? Or is it this graph? Okay. Let's look at them all together. What are the differences? Okay. We eliminated this guy because that line is not in the right place. So we know it's not him. Here we have y equals 3 up to 0. Here we have y equals 3 up to and including 0. Here we have y equals 3 up to and including 0. What is our rule? When x is a number less than 0, right? We have no equal sign, so it can't come up to 0. It has to be a number less than 0. This says less than 0. These two, however, say less than or equal to 0, right? This filled in circle means it includes 0. Includes 0. Right? But it has to be a number less than 0. Includes 0 would be x is less than or equal to 0. That's not true, right? This is x is less than 0. It does not include 0. So this is our correct answer. It's the only one that can be true based on y equals 3. Y equals 3 up to 0, but it stops right at 0, which means we need a whole at 0. We can't include 0. Good. What was the other one? The square root of x when x is greater than or equal to 0. Greater than or equal to 0. So when it equals 0, it'll be at the square root of x. That is for when x is greater than or equal to 0. That's what that whole means. That does not include 0. This one does include 0. Does not include 0, does include 0. Includes 0, includes 0. Includes 0, does not include 0. Okay, so just make sure you understand what the open circle, we call that, and the closed circle mean for those kind of questions. All right, those are tough ones. Question 36 is the same. So select the graph of the piecewise function. Oh, sorry, we forgot to write the domain. So we picked one. That's our answer, and we need to decide the domain, okay? Not the range, just the domain. What is the domain of this graph? And I know this is probably, we're reaching maximum complexity, right, with this question. So we've already decided which one of this represents f of x equals 3 for x is less than 0, and f of x equals the square root of x when x is greater than or equal to 0. We found that on the graph, and now we need to find the domain. We do not need to worry about the range. We just have to remember, what is a domain? The domain is all possible x values, right? Don't overthink this, okay? This is going off the screen this way. This is going off the screen that way forever, okay? So what are the possible x values? Everything. Negative infinity to infinity. There are no holes, right? There's one hole right here. There's a hole at 0, but it's filled in right here. It goes forever in the negative infinity direction. When it gets to 0, it jumps down here, and then it keeps going to positive infinity. So it starts at negative infinity, goes over to 0, jumps down, and goes to positive infinity. So your domain is just negative infinity to infinity, okay? We know that those only ever get parentheses, infinity symbols, okay? All right, next one, same thing. F of x is equal to x plus 4 if x is less than negative 1. F of x equals x plus 4 when x is a number less than negative 1. Okay, so that means we're going to be looking at this line where x equals negative 1, right? That's where it's going to make its change. F of x is x cubed when x is a number bigger than and including negative 1. So at negative 1, it's going to jump from x plus 4 to x cubed. Okay, it's going to jump. At negative 1, it's going to jump from x plus 4 to x cubed. Oops, see how this graph jumps? Right at negative 1, it's going to jump from x plus, sorry, couldn't even see that. Right at negative 1, it's going to jump from x plus 4 to x cubed. It's going to jump from x plus 4 to x cubed. We need to decide what x plus 4 looks like as a graph, right? Because before we knew what y equals 3 looks like, right? And then we just found our answer based only on y equals 3. Now we have the example x plus 4. So let's look at that in Desmos if we want. We go over to the graphing calculator, y equals x plus 4, right? What you can do now is go up to edit list because you have a y equals, look at your table, okay? We might need to zoom out a little bit. When x is -2, y is equal to 2. When x is -1, y is equal to 3. When x is 0, y is equal to 4. And when x is 1, y is equal to 5. When x is 2, y is equal to 6. So those are some of your points. It's going to be above, right? Above the origin, and it's going to be going in a positive direction, right? Let's look back at our examples. So it's going up, oops, going up, right? X plus 4 should be happening when x is a number less than -1. So x plus 4 should be going up until we get to x equals -1. Here, it's after x is -1, right? It should be before x equals -1, we should be seeing the equation x plus 4, okay? So that looks true, that looks true. That one looks true. This one looks like they reversed them, right? It should be looking like this. But here they switched the places, right? We have x plus 4 after x equals -1. That's the wrong answer. Okay? So all of those look the same, right? The difference is this whole, what should we call it? Circle? Is this circle empty or filled, right? F of x equals x plus 4 when x is a number less than -1. Less than -1 does not include -1. Not including -1. What's the symbol for not including -1? It's that the hole is empty. The circle is empty, all right? Because this circle is not empty, it cannot be this option. Right? Because it does not include -1. That means that there needs to be a hole in the graph at -1 for x plus 4. Okay, so we've eliminated this one because that includes -1 and we do not want that. We've eliminated this one because it's backwards, right? It might be this one and it might be this one. All right. Now, what is the difference between this graph and this graph? Those look to be the same graphs, right? And we can assume that that is the graph of f of x equals x plus 4, followed by the graph of f of x equals x to the third. You're welcome to put it into Desmos to make sure that that's true, but I think we can tell that it's true. So the only difference is that now we have this starting point. Should this starting point be empty? Or should this starting point be filled in, right? So let's describe what's happening. F of x is equal to the graph of x plus 4 when x is a number less than -1. So right here, it does not include -1. It does not include -1. So we're jumping. Where are we jumping? We're jumping down to x cubed. What does it say about x cubed? X cubed when x is a number bigger than and including 1. And including means that that hole is filled in. Not including means that that hole is open, right? So f of x equals x cubed needs to be filled in because it says including, right? Which one is filled in? This one. So this one cannot be the answer because it does not include -1 there and it does not include -1 there. Because of this symbol, this equal sign, we know that this should include -1 for that part of the graph. X plus 4 up until and not including -1, jump down to -1 at x cubed is greater than or equal to -1. What is the domain? So we eliminated all the other ones, right? So this is our answer, our correct answer. What is our domain? Again, the domain is all possible x values. We start over here. So it's clearly going from -infinity. Here it jumps down and then it keeps going forever. So that's to positive infinity. We're going to say it's from -infinity to infinity as the domain. Okay, we got one more of these. Question 37 asks us, for the following exercise, select the graph of the piecewise function and write the domain in interval notation. Sorry, you couldn't even see that I was reading it. We have f of x equals x squared when x is less than 0 does not include 0. Okay? F of x equals -2 minus x when x is greater than 0. Again, does not include 0. Does not include 0. Neither of them include 0. Okay, I want to note that right now. Does not include 0, does not include 0. Before we even pick what graph it is, I want you to see if it does not include 0 here and it does not include 0 here, your domain, instead of going from -infinity to infinity, like the other two examples, we're going to go from -infinity to 0, and then from 0 to positive infinity, because we had to leave out 0. This one doesn't include 0, and this one doesn't include 0. That means your domain has to have a gap at 0, okay? It's not -infinity to infinity because there is no f of x for 0. If f of x is 0, that's just a hole in the graph. What does a hole in the graph look like? It looks like both of these are open circles, okay? That cannot be a closed circle because x squared when x is less than 0. This is the symbol for less than and including 0. That would be for x is less than and including 0. That's not what they gave us, okay? Here, this one, that would have to be x is greater than and equal to 0 because that hole is filled in. That's not what they gave us. They gave us x is equal to 0, or sorry, x is greater than 0, right? This one's okay, right? X is less than 0, x is greater than 0, okay? So we can eliminate the ones that have the holes filled in because that includes 0. They did not give us the option of including 0, okay? Now we just need to decide when x is less than 0, it's x squared, okay? So this side of the graph should look like the graph of y equals x squared. This half of the graph should look like y equals -2 minus x, okay? This half of the graph should look like y equals -2 minus x. This half of the graph should look like y equals x squared. All right, so think about it. Think about our two options. I want to fit them both. All right. This needs to look like y equals x squared. Which one of these looks like y equals x squared? Let's make the table of values, right? X, y. When x is 0, y is 0. When x is 1, y is 1. Well, sorry, we have to only go on the negative side. When x is -1, y is 1. When x is -4, y is 2, right? Oh, sorry. That was the square root. -1, 1. When x is -2, y should be 4, right? -2 up to 4, -1, 1, right? If we try to do that over here, 0, 0, it's not there. -1, 1, it's not there. -2, 4, it's not there. So we made a table of values, and this is the only one following the table of values, all right? We can do the same thing for the other side. Y equals -2 minus x. If x is 0, -2 minus 0 should be -2. So 0, -2, right there. +1, -2 minus 1 is -3. 2, -2 minus 2 is a -4. We can find all of those points, right? 1, -3, 2, -4. So this one is true, okay? Even though the 0, -2 is not filled in, it's still on the graph, all right? It's not true, but it's on the graph. A hole in the graph. All right, so that's how I'm going to pick this as my final answer. We already found the domain. It's not -infinity to infinity because it doesn't exist right here. Those two holes mean we have to leave out the 0. So -infinity to 0, jump, 0 to infinity. All right. The following is the graph of the function f. Find the intervals on which the function is increasing or decreasing and use interval notation. All right. Let's just look at this. And increasing and decreasing are like positive and negative slope, all right? Anything that's going like this is decreasing. It does not matter where it is. If it's down here, if it's over here, if it's slightly decreasing or sharply decreasing, okay? That is decreasing. This is neither increasing nor decreasing, right? It's staying the same. And then this is increasing. All right, so now I have a guide. If it's going down, it's decreasing. If it's going up, it's increasing. Where is it going up? From here. That arrow means to infinity, okay? Decreasing. So when I encounter it, here's an arrow. And anytime it's going down, that's decreasing, okay? Where is it decreasing? It's decreasing from -infinity until 3. And then it stops decreasing, okay? Oh, yeah. So from -infinity to right here, it's decreasing, okay? Increasing. Increasing is going to be from right here, x is 3, forever, okay? And for increasing and decreasing, we always use parentheses. You never need to use the brackets, but if you get it wrong and it's only because of the brackets and I go over it because you show me your notes, I will. It's a small mistake, right? So increasing, don't get it confused just because I started with decreasing because I saw it first. They're asking for increasing. So increasing is between 3 and positive infinity. Decreasing is between negative infinity and 3. Always start with the smaller number to the biggest number, smallest number to biggest number. Good? Same exact thing, okay? Where is it? What were the colors we used? We used green for decreasing. This is going down. This is going down. Where is it increasing? It's going up. It's going up. Okay. And remember, we're only worried about the X values, nothing about the Y. It doesn't matter how far it's going up or going down. So we're only looking at the X. Here, X is -4. So it's decreasing. -4 until -2. Union, because there's another one, 0 to 2. That is where it is decreasing from -4 to -2, -4 to -2, and then from 0 to 2. Where is it increasing? It's increasing from -2 until 0. And then from 2 to 4. All right. Constant would mean it is flat. There is no interval on which it is constant. And so you just want to write that as DNE. Does not exist. Okay. Here's a graph of the function f. What are the intervals where it is increasing or decreasing? Increasing. If it goes off the graph, that means it's an arrow. It's increasing from negative infinity until right here, which I'm going to call -2. That's -2, 12, right? Then it starts again, right? That's all down. And then right here, it's going to start again at 2, -16. Okay? So here's -2, 12, and 2, -16 are the two change points. That's where a turn is happening, right? So it's increasing from arrow is negative infinity until -2. Remember, we are only worried about the X value, not the Y value. Union with 2, right? Until infinity. Oh, sorry, you couldn't see that. Where is it decreasing? Between -2 and 2. It is decreasing for that whole point. All right. Estimate the point at which the graph has a local maxima or a local minima. Local maxima, we kind of already wrote it, right? Maxima is the highest point. The highest point is -2. I said 12, but I think it's 16 because it looks like an even graph, and this is definitely -16. So I just looked at that wrong. -2, 16. Local minimum is +2, -16. Notice that your local minimum has a positive X value and negative Y value, okay? Don't worry that we're asking for the smallest point and you put a +2. That 2 is to find it on the X-axis, okay? We're trying to find the lowest point on the Y-axis, and it happens at 2, but it goes until -16. The highest point happens at -2, but goes up to 16, all right? Question 41. Look at the function on the graph to the right. It has a relative maximum of, and they kind of marked it for you, right? The relative maximum is at the point 2, 1. right? The function has a relative minimum at, see if I do better this time, 8, -5, right? And so this is all about writing it in with the standards that they are using, okay? Because it looks confusing. The function has a maximum of means how high does it get? Has a height, how high? What is the height? Has a relative maximum of, how high does it get? 1. At x equals 2. Where? Okay, so the first blank is how high did it get? It got up to 1. Where did that happen? At 2. It got up to 1 at 2, at x equals 2. The relative minimum, how low did it get? It got to -5. Where did that happen? It happened at x equals 8. All right, so that's all about syntax. Just be careful with the syntax. The function is increasing. Remember, increasing here and here. It does not matter if it's above or below the x-axis. Where is the graph increasing? Increasing means it has a positive slope, okay? It's increasing from -infinity. It stops increasing at 2. It starts increasing again at 8 and goes on forever. The function is decreasing between 2 and 8, right? From 2 to 8, we're decreasing. The domain of the function is, what are the possible x values? All real numbers. Has an arrow going this way on the x-axis, has an arrow going this way on the x-axis. So from -infinity to infinity. The range, where is it on the y? From way down here to way up here. -infinity to infinity. Good. All right, guys, we're almost done. We have 1, 2 more questions. All right, find the information for the function graph below. State your answers using interval notation. Assume arrows if no symbols are shown at the ends of graphs. That should just be at the beginning of our exam. All right, the coordinates of the local maxima. Local maximas. Remember, the local maxima is just a hill, right? That goes down on both sides. So we only have one local maxima. And what is its coordinates? The coordinates of that point are -2, 8. If you had another one, you draw put a comma and then draw the next point, right? If it was more like then this would be a local maxima, this would be a local maxima, this would be a local maxima, right? Even if it was like, those would all be local maximas. It's anything that is a hill. The top of the hill is your local maxima, all right? Local minima, right here, because it's a dip where both sides go up, right? So that is at the point 2, -8. The absolute maxima is the highest point, right? The highest point. The highest point is right here. That's at the point 410. Now, absolute minima, should we say it's this because that's where the graph ends and it's going down? Or should we say it's the absolute lowest point? We're going to say it's the absolute lowest point. So it's going to be the same as your local minima, 2, -8, because not only is it a local minima, it's the lowest point on the graph. Good. All right. Last one, guys. Estimate the absolute maximum and absolute minimum of this graph. The absolute maximum is right here. How high does it get? It gets to 54. What is the absolute minimum? What is the lowest that it gets? The lowest that it gets is negative 54. Okay, they didn't even ask for a point. They just said, what is the highest point? Highest point on the graph is 54. What's the lowest point? Doesn't even spell it right. What's the lowest point? The lowest point is negative 54. All right, guys. Great job. That was a very long video, and I hope that it was helpful, and yeah, that you feel very confident going into this exam. Have a good day.